Assalamu alaikum wa rahmatullahi wa barakatuh. Alhamdulillah, we meet again. Uh, how should I start this? I know that the going has been a little bit tough, or maybe very tough for some of you for these past few sessions or these past few weeks, where we touch upon one of the what do you call it most complex, intricate theories in physics and astronomy, or you combine them two, become astrophysics. We talk about quantum physics, quantum mechanics, and how it relates to our belief in Qadar and Qadar. We talk about Planck's time and also Planck's length and how they relate to Allah subhanahu wa ta'ala. How we want to, what do you call it, tie them up with our belief, right? We talk about subatomic particles. These are all things that you won't normally discuss, or you won't normally find it in any other ordinary lectures, right? These topics, actually, in science or in physics, are only discussed, right, and touched upon at least university level, right? When they talk about quantum physics, when they talk about Planck's times, Planck's length, all these are being actually touched at university level if you study physics, okay? But we need to understand these so-called advanced theories in science, because we are talking about something that is fantastic, right? Something that ordinary mind cannot actually comprehend. We are talking about the moment of creation. So we talk about the moment of creation, the Big Bang itself, all these fantastic theories, advanced theories in science and physics, they need to be understood first. Then you can have a bigger picture. And that is why I touch upon those things for the past few weeks. I did not go into much detail, right? I just give an overall view. But I apologize if some of you find it difficult going and difficult to understand. But just a 40 minutes lecture, 45 minutes lecture, and you want to compare it with those who study at university level physics. That is something that is, well, quite extraordinary. Okay, if you really understood it. So I quite understand if you could not find the things that I explained before understandable, right? All of it is okay, but you need to do your own research. You can read my book, or you can read other books, right, to deepen your knowledge on what I have discussed so far. Okay, now let's put everything aside. Let's look at the moment of creation itself. Last week, right, I mentioned that the moment of creation, which happened at when time was 0.00000001 with the number of zeros as 44, and that is called as Planck's time. Okay, so you put down zero, you put down dot, and then you put 44 zeros. If you have 44 zeros followed by 1, that is Planck's time, right? Then that is the time taken for light to travel, right, at Planck's length. And what is the Planck's length? It is 0.0000 followed by 30, about 33 or 32, what do you call it, zeros of the size of the proton. You see, the size of proton is so small, right? The very tiny fraction, very tiny fraction of the length of the proton, if for the light to travel, that time taken for light to travel is Planck's time. So you can imagine how fast that is, right? How very thin slice of time that is. So the universe starts at Planck's time, and the size of the universe at that time was Planck's length, right? 10 to the power minus 35 meter. Now, if you look at this, I'm going to skip this because this chart actually doesn't really matter that much lah in our discussion about the creation of the universe according to Islamic tradition. But let's look at this, right? This is an important chart, right? You look at the, what they call it, the x-axis, this is time, and the y-axis is meters, okay? Now, the universe starts as 10 to the power of minus 44, which is around here, right? At this point here. So you draw a line there, right? Across the x-axis here, perpendicular to the x-axis is 10 to the power of minus 44 second. This is this point here, this corner here is 0 second, and 10.4 minus 44 is here, and all the way to 10 to the power of minus 25 second, to 10 to the minus 15 second, to 10 to the power of 5 second. Now 10 to the power of 5 second means what? It is 1 followed by 5 zeros. 1 followed by 5 zeros, which is what? Which is 100,000 seconds. Okay, then 10 to the power of 15, which is 1 followed by 15 zeros. And that is trillion and trillion second. So that is almost close to our current age of the universe, right? It's around here. So 10 to the power of 15 second. Now, at 10 to the power of minus 45 second, a very, very thin slice of time, right? When the universe starts, I tell you, the universe never starts at 0 time. The size of the universe is Planck's length, which is 10 to the power of, here, 35. Okay, so 10 to the power of 35, which is somewhere here, not here. Although this is meters, sorry, this is 10 to the power of minus 35 meter, yeah, correct. So it should be around here. Okay, so the universe starts from here. All right, now the universe expanded. We do not know how the universe, why the universe expanded, but we can speculate that the universe expanded because of this force, which was speculated by this British physicist by the name of Peter Higgs. And he speculated that there was this, what they call it, energy force that was pervasive in the very, very early universe when the universe began, right? At that point, at Planck's length time, right, it was full of that energy. And this energy, right, was carried by this particle called Higgs boson. Now, if you remember, boson is the name of any force-carrying particles, right? So it can be considered as the photon is also a boson, because photon carries the energy of electricity and magnetism, right? And light, right? Lasers consist of photons, right? So that is, the particle belongs to the family of boson. Then we have the strong nuclear force and we have the weak nuclear force. All these particles belongs to the family of boson because these particles carry force. Now, so we have another particle, you call it as Higgs boson. Some people, smart elect, say that this is a God's particle where they just give name. So it's not something that is really God particle. Everything belongs to God, of course. Okay. Now, so he speculated that the early universe was full of energy, and this energy that propels the universe to expand. But the universe expanded at, what do you call it, a constant rate. At a constant rate. Now, if the universe continued to expand, the early universe, if it continues to expand at that normal rate, you wouldn't have the current size of this universe. At most, you have a universe the size of between our galaxy to the Andromeda galaxy, which is about 2 million light years across, or altogether will be 4 million light years, something like that. Not that big, right? Not that big. So if the universe is very calculated, of course, if the universe expand at that rate, then if that force of expansion, then the universe will be very small indeed, not the current state of the universe, which is very large. Now, to have like our current universe, which is so huge, and I explained to you before, right? For example, right, from us to the furthest star, the furthest object that we can see, which is called as quasars, it is about 13 to 14 billion light years away. 13 to 14 billion light years away. It means that when we look at that quasar, right now, that light exited or escaped from that object 13 to 14 billion light years ago, before even our sun was formed. So it was traveling, and until now, just now that the light reached us and we know that, oh, okay, there's object over there. Right? So what's happening to the object right now, we do not know, because why? What we're looking at the past. But when we are looking up to the stars, we are looking to the past. We do not know the current state right now. We can speculate. We can say that, yeah, the current state is just like before, because we have statistics, we have what you call it, projection, right? Nothing changed much. Then the stars are still there, right? But are you sure? We do not know, right? We really do not know, because we're based on statistics. Okay, so that's how vast our universe is, 13.5 billion, 14 billion light years, right, from us to the further stars. And for these further stars to another further stars, you add them together, it can be easily be 30 billion light years across. So that huge, the universe, 30 billion light years. From one end to the other end, light need to travel, and light will take 30 billion, 30 billion light, 30 billion years to reach towards the other end. Compare it to just our galaxy, right? From one end of the galaxy to the other end of the galaxy, it takes around just 100,000 years for light to travel. So for one end, if you shine a laser, the light will travel and reach the other side after 100,000 years. That's not big. That's quite small, right? What, just 100,000 years across? Of course, there's more than lifetime of our civilizations, right? You know, the earliest civilizations, the Sumerian, the Egyptian civilizations, they existed about just 6,000 to 7,000 years ago. So quite short, right? 6,000 to 7,000 years compared to 100,000 years. So that is the comparison of the vastness of this universe. Now, to have this vastness of universe, right, something must happen at the very early moment of creation, when this universe came into being, right? Something must have really pushed the universe, accelerated its expansion, right, so fast that after that, because of that, it reached our current size of the universe. If nothing happens, the universe will be quite small, very small, right? Just like the size that I mentioned to you just now, right? No bigger than maybe our local clusters of galaxies. So something happened. Now, what is that thing that happened that pushed the universe to accelerate so fast that the universe expanded so huge at a very, very short period of time? It was speculated, it was calculated, and in about 1970s, right, two physicists actually proposed the idea of, or proposed this theory of extraordinary expansion of the early universe. They call it the theory of inflation, right? This is the one. Now, inflate means to make it big. If you inflate a balloon, it means you make the balloon very big, right? So that's mean inflate. The opposite is deflate. You deflate and then you compress it and it's finished, right? So the theory of inflation means that the universe starts very small and something happened that caused the universe to really expand so fast, right? In a very, very short period of time, that the universe was blown up from the size of a molecule to the size of, for example, for the size of a molecule to the size of a solar system, right? In a time that is faster than 1,000,000,000 times of a blink of an eye. You blink an eye, that's fast, right? 1,000,000,000 times faster than the blink of an eye. That is how short the time taken, right, for the universe to expand to that size. Some say that from the size of the pea to the size of our current universe right now, according to some calculations, right? So if it is the size of a molecule, if it's the size of molecule, it means that it expanded to the size of the solar system, right, in very short periods of time. But if it's the size of a pea, then it expanded to the size of our current size of the universe. Imagine that's how, how fast the expansion is. Something propels the universe to really expanded at a very, very fast rate in a very, very small period of time. So if you look at this graph, this blue bar, right, which is a very, very thin slice of time from 10 to minus 35 to 10 to minus 32, 33 second, around that, right? It is very, very short period of time, the universe expanded dramatically, exponentially, or you can see that a very huge expansion of the universe. And then after that, as soon as it started, it ended. Right? The expansion stopped. So you can imagine, like, for example, it is going out its own sweet way of expanding. Then suddenly something push it to expand very fast, and it shoot up, become very big, and then suddenly it stopped. And then the normal expansion continues. So this very short period of time, right? This physicist by the name of this American physicist by the name of Alan Guth, right? He proposed the theory of inflation, and this theory, right, has been, of course, it was on mathematical equations, right, in the first place, but it has been proven by many scientists after him. So much so that the majority of scientists, right, vast majority of scientists right now accept his theory, and that is why he got the Nobel Prize recently, right? This year, or is it towards the late of last year? Last year, right? Alan Guth, he is still alive, right? A very old man, 80 plus already. He got a Nobel Prize for that theory that he proposed when he was very young man, right? 20 plus years old in 1970s, the theory of inflation, because it has been proved by observations. Okay, so now what is that thing that propels this expansion? He just proposed some energy, but then the scientist that I mentioned to you, the British scientist by the name of Peter Higgs, right? He proposed that energy, right? That space of energy. They call it as Higgs field, of course, according to his name, right? He said this is the field or the energy that propels the universe to accelerate very fast, right? At the blink of an eye, or faster than a million billion times, then faster than the blink of an eye, the universe expanded very fast, and then suddenly it disappears. That field decay, the energy decays, and then the universe started to expand at its normal rate. So it went out happily expanding like before, right? So the graph will be like this, okay? Well, you can take this blue thing, it is expanding. It was expanding happily, then suddenly something push it, and then it become very, very big in terms of radius. And then after that, that thing stopped pushing, and then it continues its own normal expansion, right? And until now. So this thing that's been pushed right, is called the Higgs field, and the particle is called the Higgs boson. In 1970s, 60s, 70s, right, Peter Higgs proposed that Higgs boson. Only quite recently in 2012, right, that the, what do you call it, the European Laboratory of Particle Physics, right, they found that particle. So imagine after close to 50 years, something like that, right, they found the particle, and Peter Higgs was still alive. Oh, he's still alive right now until now. So he was, of course, very happy that his theory has been proved right now, that Higgs particle actually exists, right? And if Higgs particle exists, then the theory of inflation actually happens. And that is why Alan Guth got the Nobel Prize last year, right? Because it has been proved, all these experiments and discoveries proved the theory of inflation. Now, the theory of inflation is very important because it differentiates between pre-inflation, which is when the universe was very, very small, to post-inflation, when the universe, right, continues to expand, but it's already being being blown up into a very, very vast sphere of space, right? Very huge universe of space. Some calculations say that after inflation, right, happened, the post-inflation, the universe, right, was at the size of our current universe, and it continued to expand after this. So it means that our current universe, right, is much, much bigger than what we can observe. So we observe the furthest star is 14.513 billion light years away, right? But that is just part of the observable universe. The non-observable universe, which we can't see forever, it is being hidden from us forever. Allah SWT does not allow us to observe it. That is bigger than our current observable universe. So if you look at this, right, there's a Big Bang. Then there was the inflation period, and the size of the universe, this part here is the size of the universe, and suddenly boosted up, right? It blown up to a very huge size, to about current or bigger than our current observable universe. Then after that, it continues to expand, right? But it's decelerating acceleration, if you can if you can understand it lah. It is accelerating but decelerating. It is decreasing acceleration. You know, there is a constant acceleration, and there is increasing acceleration, and there is also decreasing acceleration. Acceleration, for example, constant acceleration is what they call it, the gravitational acceleration. You drop something, anything from anywhere, that thing will fall at a constant speed, regardless whether you drop a metal ball or you drop a feather. Both will fall at the same speed. He said, no, that's not logical, right? The metal ball will drop faster than the feather. Well, this has been proved, right, by scientists. They dropped from the Leaning Tower of Pisa, right? This scientist, I forgot his name, I think, forgot his name, really forgot. So he dropped a metal ball and a feather, and both reach the bottom, right, of that tower at the same time. So it shows that what? It shows that the acceleration is the same. Acceleration is the same, right? Only that the metal ball will hit harder because it carries more energy, and the feather will hit it very lightly because it carries less energy, is not that heavy. But we will reach the same time. If you drop it, you can do an experiment yourself. You drop two things, maybe you can drop 1 kilogram of thing, another 5 kilogram of thing, and you drop it from a height. You can see that both will reach at the same time on the floor. Okay, so that is constant acceleration. Now increasing acceleration means that the acceleration increase as you get closer and closer, or as you get you will get faster and faster and faster and faster. The speed that it changes, right, is can you hear me? All right, I don't know what happened just now, right? Technical glitch. I don't know really what happened. I think the universe is angry with us. Okay, let me see. Where is that PowerPoint? I got to share the PowerPoint again. Okay. All right. Okay. Let me share again the screen. Yep, this is the one. Okay, Alhamdulillah. Okay, back to business. Alhamdulillah. Okay, so the universe is accelerating, but getting slower and slower. Now, because of the inflation, the size of the universe is very, very big, right? It's huge. Can't even imagine it. It is more than what we can observe. So according to calculation, right, our current universe, which is this first heaven, Right? When we're talking about the first heaven, we're talking about our current universe. Allah SWT mentions in the Quran, As-sama'ud dunya, the nearest heaven to us, which is our own universe. So this universe is actually very huge, bigger than what we can observe. So our observable universe is just about 20%, 10 to 20% of the actual size of the universe. Now, what is the actual size of the universe? It's based on speculation, right? And calculations. Calculations vary widely from one calculation to another. So nobody really knows, right? Nobody really knows the actual size of our current universe. Nobody. But what we know and what has been agreed upon is our current size of observable universe. And this is just a small piece of our non-observable universe. Like I said, 10 to 20% of our universe. So imagine this vast universe with billions and billions and billions of stars. You have more than 100 billion galaxies, more than 100 billion galaxies in this observable universe. And I mentioned this before. You can go throughout my past videos, right? The past lectures. And each galaxy, more than 100 billion stars. Our galaxy is 100,000 light years across, Milky Way galaxy, right? It is orbiting around a group of galaxies. We call it as local cluster of galaxies, consists of close to about 20 galaxies, right? Rotating, orbiting around each other randomly. Some will mix together, like for example, our galaxy and our nearest galaxy, Andromeda galaxy, which is actually bigger than our galaxy, right? This has been observed that we are moving towards Andromeda galaxy and Andromeda galaxy is moving towards us. In other words, these two galaxies, our galaxy and Andromeda galaxy, will one day, we can't escape from that fate, one day in the future will collide. These two galaxies will collide and then merge together to form one huge galaxy. So there'll be some violent events, right, far in the future. When will it be? Don't be scared, right? It will be billions of years in the future. So it's not to be tomorrow or another 1,000 years or another million years. No, no, right? But it is moving closer towards each other. So galaxies orbiting, merging, hitting, right, colliding against each other. This is called local group of galaxies. And then we have other local group of galaxies. So we have groups of galaxies here, groups of galaxies there, groups of galaxies there. So we have billions of groups of galaxies. And now some groups of galaxies gathered together, and this group of galaxies, right? They orbit among each other to form one mega group, mega cluster of galaxies. And there are millions of mega clusters of galaxies across this universe. So huge. And there's just observable universe. And there's just observable universe, you know? The furthest we can see, let's see if we are in the middle, the furthest star will be right at the edge here is 14.5 to 13.5, something like that, right? Billion light years away. Beyond this, we do not know what happened. That's how vast Allah's richness. That's how vast Allah's kingdom is. Right? So this is just one universe. This is just the nearest universe to us. This is just the first layer of heaven. What about the second layer of heaven? What about the third layer of heaven? The first layer of heaven is that so huge. And imagine Rasulullah SAW was invited for that night journey, Isra, and then after that, the ascension towards the heavens, Mi'raj. And Rasulullah SAW traveled all the way through all the seven heavens. So Rasulullah SAW actually escaped from this first, what do you call it, layer of heaven, which is our universe, our physical universe that is inclusive of observable and non-observable universe. And our observable universe, that huge universe of us, is just about 10 to 20%. We do not know for sure how much of the non-observable universe. What is for sure is that the non-observable universe is much, 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 much bigger than our observable universe. That is for sure. So Rasulullah escaped that and went to the next layer of heaven, and then after that, next layer of heaven, and next layer of heaven until the seventh heaven, and then after that, straight to Arash, and then receive the command from Allah subhanahu wa ta'ala for that 5 daily prayers. So subhanallah, that's how great Allah's kingdom is, right? And that is why Allah subhanahu wa ta'ala, right, reminds us of this life, which is actually nothing compared to what Allah subhanahu wa ta'ala owns and has created. Then imagine, right, the Prophet sallallahu alaihi wasallam said, every single mu'min who will live, who will reside in Jannah. I'm not going to use heaven because heaven can mean universe, right? But I've used Jannah. Every single mu'min who will reside in Jannah will have the size of its Jannah bigger than this earth and the 7 heavens. Bigger than this earth and the 7 heavens. Subhanallah. You imagine just the first heaven is already this huge. What about another 6 heavens? And this is the size of just one Jannah for that one particular person. And in Quran, Surah Rahman, Allah subhanahu wa ta'ala says what? وَمِن دُونِهِمَا جَنَّتَانِ. There are actually 2 heavens for every single individual who will live in Jannah. There are actually 2 Jannahs reserved for every single mu'min, subhanallah. 2. And each one is bigger than the earth and the 7 heavens. You see how huge Allah's ni'mah, Allah's blessings that Allah has bestowed upon people who believe in Him and die as a believer. May Allah subhanahu wa ta'ala make us live in this world instead of believe in Allah subhanahu wa ta'ala, instead of husnul khatimah. Amin ya rabbal alamin. That is what awaits us, inshallah. Amin ya rabbal alamin. So there will be no boredom in Jannah. You have more than a lifetime ahead, not even a lifetime, infinite time for you to explore your own backyard of Jannah. You know, not talking about other people's Jannah, just your own Jannah. You'll be so busy exploring and this thing, and you can still meet other people, this and that. That is beyond our imagination. So what we have learned right now is just, for mu'min to increase our belief in Allah subhanahu wa ta'ala, to put things in perspective. This life that people have been racing, right, to get wealthy, right, to be rich, right, to accumulate as much money as one possibly can. But that is nothing compared to this just one universe. That is just nothing. There's nothing compared to just the observable universe. That is nothing just compared to our solar system. Not talking about our own galaxy. Just a solar system. There's nothing. People talking about numbers. They're talking about dollars and cents. Yes, about numbers. You don't carry numbers when you die. You use that numbers to purchase things. If you don't use that numbers to purchase things, that numbers will remain until you die. Then after that, that numbers will be passed on to your rightful beneficiaries, and they will use the numbers to whatever they do they want. So money, currency is just about numbers. It's just about points. It's like people playing games. You accumulate points, and then either you use that points or you just let the points increase and increase and increase. Look at all those billionaires, right? Super billionaires in this world. What are they going to do? What are they doing actually with all the wealth that they have? Look at Jeff Bezos, the owner of Amazon, the richest man on earth. 130 billion dollars in assets, like in stocks, right? In actual fact, his money is not that much. It's about just 40 to 30, maybe 60 billion years. But what's going to do? What did he do with all this money? What did Bill Gates do with all the money, the wealth that he had? Both of them donated that huge portion of their money because they do not need all that surplus of money. Right? We don't actually need all those much money to live in this. So they donated. They use it for charity, for foundation, and so forth. So to put things in perspective, yes, we cannot live as poor people in this world. Allah subhanahu wa ta'ala, Rasulullah sallallahu alaihi wasallam actually praise Muslims who have wealth. but know how to control their wealth, right? Because their wealth will be used for them to prepare for the life in the hereafter, so get a better life in the hereafter, right? And the Prophet ﷺ said in the hadith, "Kadal faqura yakuna kufra," right? Poverty will nearly cause someone to leave Islam, to become a disbeliever because of poverty. But if you have wealth, then Alhamdulillah. But Islam does not encourage us to pursue wealth just for the sake of wealth. We pursue wealth for the sake of the hereafter. The money that we have, to use it for our life in the hereafter. So the current state of universe, because of this inflation, right, that blew up the small pre-inflationary universe, from that very, very small, tiny universe to such a huge universe that encompasses the non-observable and observable universe, right? These things are all lessons for us to learn. Actually, it's not just for us to listen and then and wonder and then ho-ha like that. No, something for us to learn. What are the lessons that we can take from all this knowledge that Allah has opened up for us, right? Don't be like the non-Muslims who study just for the sake of studying and then, oh, okay, these are the facts, this and that, and that's it. But no value to the knowledge that they gain. We want values from the knowledge that Allah has bestowed upon us, so that it will be better for us in the hereafter. Okay, so these are, they will call it as inflationary universe, this part here. Now, some questions and answers before we end our session tonight. This is going to be the last session that talks about the scientific aspect of the Big Bang. After that, we're going to move on to the Islamic aspect of the Big Bang. Now, what caused that inflation? Quantum fluctuation. That's why we need to study quantum fluctuation. And quantum fluctuation, it means that at a very, very thin slice of time, right, which is 10 to the power of minus 333 second, which is 0.00 with 33 zeros altogether, then followed by 1 second at a very, very early part of the universe, right? Time is unstable, that somehow or rather energy in that, what do you call it? That energy caused the universe to expand. And that energy comes from what they call as a Higgs field, and this particle is Higgs boson. Now, it is very short because of quantum fluctuation again. So it at a very, very this what they call it, unstable time, right? This very short piece of time is unstable time. When this at very, very thin slice of time, things are unstable, right? Energy can change to matter, matter can change to energy. So matter in that time converted to energy, and it was a huge energy. So that energy, which is called the Higgs field, caused the universe to expand to that huge size that we have right now, right? And then as soon as it caused the universe to expand, then because of the instability of that very thin slice of time, then the energy converted back to matter. The energy converted back to matter. So you have all these matters, which is subatomic particles, that were distributed all across the universe. And that's why we have stars all across the universe, right? The energy stopped and caused, right? The energy stopped the expansion, and whatever leftover energy, right, was converted into subatomic particles. Okay. Now, not all energy was converted back to subatomic particles, which are mass, right? Some of the energy, right, converted to particles. Some of the energy, according to Alan Guth theory and all other physicists that came after him, right, say that some of the energy actually was being reinforced, become stronger. And because it becomes stronger, right, it actually caused the expansion to grow. So you have this universe growing, right, at a very small state, and then it grows very fast suddenly, and then it stops. But this is just the total size of the universe. But at certain points on the space in this universe, right, certain points, the energy actually did not converted into mass, but the energy actually increased in intensity and its power, right? That cause another universe to expand from that point in the universe. So this universe expanded. It's a secondary universe that appeared from the first universe, and it expanded. And then after that, it stopped because of quantum fluctuation. But again, because of quantum fluctuation, there are certain space in that second universe where the energy actually reinforced itself, and therefore another third universe appeared, an offshoot of that second universe. And then after that, it stopped again. And then after that, another fourth universe expand, and it continues for infinity. And that is why Stephen Hawking, right, he said that, of course, we can't accept it. He said that according to his calculation, because of this expansion of universe from another expansion of universe, right? So a universe that was being born from an earlier universe, and this universe gave birth to another universe, and that universe gave birth to another universe. So in the end, you have bubbles of universe, and the number of bubbles of universe, actually, according to him, is 10 to the power of 700. Cannot even imagine, right? Our universe is just 10 to the power of, where is that thing? This one, right? Our universe is just 10 to the power of, let's say, 20 second. 10 to the power of 20 second, the time taken, right? So that is just our universe, right? But 10 to the power of 700 means 1 followed by 700 zeros. That is unimaginable. Unimaginably huge, huge, huge number. So according to Stephen Hawking, the number of universe is 10 to the power of 700 universes. That is speculation. Because of what? Because of this, what they call it, quantum fluctuation, where an early universe will give birth to a secondary universe, a child universe, and this child universe will give to the grandchild universe, and so forth, so forth, so forth, until 7 universe. And then we have bubbles of universe. Each universe is disconnected from the other universe, and so every single of this universe exists on its own, according to Stephen Hawking. So you have 10 to the power 700 number of universe. All these universes, okay, all these universes are disconnected from each other, and they have different physical properties. For example, in this universe, Stephen Hawking said, in this universe, light has a speed limit, 300,000 kilometers per second. It might be, right, the second universe where light has a slower speed or a faster speed, or where there is no gravity, so it is an anti-gravity, or where things are inverted, so this and that. So in properties that we can't even imagine, right? So that is a theory. So in other words, right, the theory of inflation coupled together with quantum fluctuation, which is what caused that inflation, right? Both of these combined together and gave rise to the theory of multiverse or multi-universes. And this actually been mentioned in our Quran. Allah SWT mentions, and we all know there are 7 heavens, and that is actually multi-universe. But Allah SWT stopped it, the number of universes, to just 7, not 10 to the power of 700. Number of universes, just 10, sorry, just 7 universes or 7 heavens. Okay, so bear in mind, because when we are going to talk about the creation of the heavens, right, into 7 heavens, when we're going to dissect and discuss the Quranic verse and also the hadith, which we're going to start inshallah next week, this thing will be referred to. I will refer to what I discussed right now, and also previous lectures about the multi-universes and how it came about, and the inflation period, right, which plays a very crucial role, right, in explaining the current size of our universe. Okay, so we have covered everything that need to be covered, right, about from the scientific point of view of the Big Bang. So inshallah, next week onwards, right, we're going to leave behind all these jargon, scientific jargons. We're going to look at the Quranic verses, and we're going to look at the hadith. And hadith, we're going to look at its sanad. It is what they call it, chain of narration, and the narrators in there to certify whether the hadith is viable, acceptable, authentic or not. And from the Quranic verses, of course, we're not going to dissect, we're not to look at the chain of narration. No. We all accept Quran is the truth. But we're going to dissect that verse itself from many points of view, especially from the Arabic language point of view, which is going to be very interesting. And also from the point of view of qira'at, of how that verse is being recited, or how Allah subhanahu wa ta'ala, right, inform us on the type of its recitation, or how it is to be recited. Then inshallah we'll start next week, inshallah. All right, so for those of you who actually stop watching my videos or stop attending my lecture because I couldn't understand all this scientific jargon, I hope by next week you come back, right? Because the discussion will be easier, right? No more scientific discussion, or no more all these particles or whatever nonsense. Okay, so inshallah I'll see you next week. Let's see whether there is a question here. Beyond our universe, second to seven universe is physical or metaphysical? A very good question, right? The second to the seventh, right? Physical or metaphysical? It depends on how we define physical and how we define metaphysical. If we define physical as in what we can measure, right? That is what they call it as measurable, observable, right? Which is empirical actually, right? Then those other universes are metaphysical universes because we can't measure them. It is beyond our measurement. In fact, we can't even measure the non-observable part of our universe. So what we can see that our physical universe is actually at least the observable part of our universe. This physical, at least it can extend to the non-observable part, right? That is, we define physical as what we can observe, empirical. But if we define physical as something that is being created from Allah subhanahu wa ta'ala from the original point, right, which is the Big Bang, right, then all the other universes are also physical. So it goes back to what you define by physical and metaphysical. If you look at ordinary definition of metaphysical, it means that something that is beyond empirical. We cannot measure, we cannot observe. We do not know whether it's actually there or not. So if that is your definition of metaphysical, then our current physical universe here, which is divided into observable, which is smaller than the non-observable part, then the non-observable part is the metaphysical universe. Only the observable part is the physical universe because we can measure, we can see, we can observe. Beyond that, Wallahu alam, we do not know what happened there, right? Are there stars there? Are there antiparticles there? Right? We do not know. We can't see. We cannot observe. So that can constitute as metaphysical, right? So it's just words lah. Okay. So that's about it. Inshallah, we continue next week. So we end our session with Tasbih Kafara and Suratul Asr. Subhanakallah bika asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Bismillahirrahmanirrahim. Wal 'asri innal insana lafi khusr illa alladhina amanu wa 'amilus solihati wa tawassaw bil haqqi wa tawassaw bis sabr. Thank you. Assalamualaikum warahmatullahi wabarakatuh.